Here's number 67. Here's the equilibrium that's happening. If you pay attention to this, you gotta be careful always. There is a solid involved in this. So remember, that is not part of our equilibrium expression. And as long as there's some solid present, it doesn't affect the equilibrium because it's gonna be a K value in terms of pressure. And the only thing causing pressure, solids don't cause pressure, so only these two things are causing pressure at equilibrium. So as long as there's some of that present, we ignore what is there. So I did set up an ice table here. Really, this is asking what are the pressures of these two at equilibrium. So what is this pressure at equilibrium? How many ATMs is this? And how many ATMs is this? It doesn't give us how much of this we had initially. We don't really need that. We know that basically they just start heating this and it starts making these two gases. So initially these would have been 0. If we think about this, for every mole of this that reacts, we produce 2 moles of this. So I'm going to put in a 2x and an x. Or for every atmosphere of pressure that this one makes, it's going to be double the pressure. We can just plug those into our equilibrium. So here's our K value. K equals products, which would be 2x, that needs to be squared, times x over, well, that's a solid, so we don't have to put anything on the bottom. So just this equals that. Well, 2x times 2x is 4x squared, times x equals 4x cubed equals your K value. It's a very common problem. Divide by 4, and then we need to cube root this. So take 0.0029, divide by 4, cube root it, and we get an x value of 0.09, which means at equilibrium, this concentration would be this pressure would be 0.09 atmospheres, and this would be 2 times that, 0.18 atmospheres. If you would plug those in, take 0.18 squared times 0.09, we should get our K value of 0.0029. So there's your pressures.